Welcome to the solutions for the Regents Motion in a Plane problem set numbers 8 and 9. For number 8, let's read and highlight important information here. You accidentally throw your keys horizontally at 8 meters per second. So that would be the VIX value from a cliff 64 meters high. That's the height. We call that dy. How far from the base of the cliff? That's the range, or the dx value, should you look for the keys. All right, so we're looking for dx. We know that horizontally, our only motion equation is v equals d over t. And we have the velocity, and we're looking for the range. So clearly what we're missing is the time. Very typical projectile motion question. What motion determines our time in the air? And that would be the vertical motion. So our approach to solving this problem is going to be use the vertical motion to solve for the time in the air, and then substitute that into the horizontal motion to find the range. So we start off with our equation that represents the vertical motion, and that would be dy equals VIYT plus 1/2 gt squared. We're given the height of 64 meters. We know that if the keys were thrown horizontally, that there is no initial velocity component in the y direction, in the vertical direction. So this whole first term is 0. 0 times t would be 0, plus 1/2 9.81 meters per second squared times t squared. We do not have conflicting directions here. Our 64 meters is down, and acceleration due to gravity is down, so we don't have to worry about sign. We solve for t. If you need a moment to calculate, pause the video while you do so. Don't forget to take the square root in order to find t. And when we do that, we get a time of 3.61 seconds. Now that we know the time in the air, we can now go over to our horizontal motion, which is Vx equals dx over t. Our horizontal velocity remains constant at 8 meters per second, and dx over 3.61 seconds. This gives us horizontal range, our dx value, by multiplying, again pause if you need a moment, to be, to 2 digits, 29 meters. So there's our answer to number 8. Okay. Moving on to number 9. Let's highlight information here. A toy car runs off the edge of a table that is 1.225 meters high. There's our dy value. If the car lands 0.4 meters from the base of the table, that's the range. So that's dx. How long did it take the car to fall? Okay, and that's the time. And how fast was the car going on the table? And that, of course, would be its velocity. We also know that because it's a table, that velocity is horizontal, making this a horizontal projectile motion question. All right, once again, to start off with A, we're looking for the time it takes to fall. Usually, when we do a projectile motion problem, we'll find that from the vertical motion. And indeed, we look and we see we have the vertical height of 1.225 meters, and that's really all we need to find the time. So we start with the equation that defines our motion vertically. dy equals VIYT plus 1/2 gt squared. As you become more experienced, what you'll learn with horizontal motion, projectile motion questions, is that you don't even have to include the VIY term. You can just drop it off. But for now, we'll just keep it. We know that our dy value is 1.225 meters. our initial velocity y component, our vertical component is 0 plus 1/2, 9.81 meters per second squared is our acceleration due to gravity times t squared. Again, we don't have conflicting directions. This vertical drop is down in addition to acceleration due to gravity, so we're all set. Solve for t. Remember, we need to take the square root when we get that far. And to 3 digits, our answer is 0.500 seconds. So there's our answer to A. For answer to B, they're asking for the horizontal velocity. That would require our horizontal equation, and the only one we have is Vx equals dx over t. Vx is what we're looking for. Our horizontal range was given to be 0.400 meters. And in part A, we found our time in the air to be 0.500 seconds. Go ahead and calculate, and we get 0.8. I believe our answer has to be to 3 digits, 0.800 meters per second. So there's our answer to B. Much more to come in class as we continue to work with these projectile motion questions.